Hello, physical science students. Mrs. Smith here again. Here is the sequel to the first screencast, Introduction to Energy Calculations. Now that you have a better understanding of the variables used, their units, and what formulas are available, we're going to do some practice. Make sure you have this handout in front of you. Make sure you also have a calculator handy. Now, if you're good at calculations and formulas and you think you can do this without my help, by all means, go ahead and get started and see what you can do. However, please make sure you come back and check your answers when you're finished to make sure you did the calculations correctly. There's a couple things that students make mistakes with in the beginning, especially with the squares and the square roots and the divisions on the bottom, things like that. So again, if you're going to try these on your own, at least make sure you come back and check your answers so that you know you're doing them correctly. All right, directions for the following problems include formulas, your work, and a circled final answer with units. That should look familiar. We know we have 3 steps to all calculations this entire school year in physical science class. Let's look at number 1. A 12,000 kilogram truck rests upon a 15-meter cliff. What is its gravitational potential energy? Remember, when you're reading a calculation, first thing you should try to figure out is, what do they want me to find? What is its gravitational potential energy? That's what it wants us to find, GPE. Now, please look at your formula sheet for gravitational potential energy. If you look at the left-hand side of that data table, it says if the information provides the mass, 12,000 kilograms, then use one of the following formulas. So you should have picked out GPE equals mgh. There's our first step. What is our second step? Fill in our data or show our work. So 12,000 kilograms, what is that? That is a mass. Rests upon a 15-meter cliff. What is 15 meters? That is a height. Oh, there's some good information. So M, mass, we just said was 12,000 kilograms. We know our height is 15 meters. What about G? Our problem didn't give us G. How am I supposed to figure this out? Aha, remember, when you are on Earth, G is a constant. G, or the acceleration due to gravity, while on Earth is always 9.8 meters per second squared. If you go back and look about halfway down on the introduction page, you can see it says when on Earth, G equals 9.8 meters per second squared. That is a constant. It will always be the same. The problem doesn't need to give it to you. You can assume. All right, then we have to fill in our height, 15 meters. Please plug those 3 numbers into your calculator. 12,000 times 9.8 times 15. Dun, 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 dun. What do you get? Big old number. You should get 1,764,000. Well, there's our number. We don't want naked numbers, though. What are our units? Go back and look. We're solving for energy. What units are associated with energy? Joules. That's it for number 1. Let's look at number 2. How high must a 60-kilogram woman stand in order to have a GPE of 5,000 joules? How high? What are they asking us to solve for? Height. So please look at your formula list. H equals, you should pick out GPE divided by mg, which remember is just a manipulation of that first formula. So let's fill in our numbers. What is our GPE? Right here, 5,000 joules. We want to divide that by our mass times our gravity. Here's our mass, 60 kilograms. And G. Wait, they didn't give us G again. Remember, it's a constant, 9.8 meters per second squared. Now, here's one place where I start seeing mistakes, is that squared. The squared is part of the units. It's meters per second per second. It is not telling you to square any of the numbers involved. So make sure you do your 60 times your 9.8 in the denominator first. Then we'll take 5,000 divided by that value. You will get 8.5 meters. If you do not use parentheses and you just throw a bunch of numbers into your calculator, you will frequently get the wrong answer. Make sure you're following the order of operations. All right, let's look at number 3. A rock resting on a 5-meter ledge has a GPE of 800 joules. What is the rock's weight? What is the rock's weight? We are solving for the weight of the rock. So go back and look at your formula sheet. If you look under gravitational potential energy, on the right-hand side of the data table, it says, if the information provides the weight or asks you to find the weight, use one of the following formulas. Weight equals GPE divided by height. All right, what's the GPE? Tells us right here, 800 joules. What is the height? It's resting on a 5-meter ledge. There is the height. Easy calculation, 800 divided by 5, you should get 160. That is our number, but what is our units? Remember, weight is a force. What did we measure forces in? Newtons. So 160 newtons is your final answer. Let's move on to number 4. What is the mass of a dog that has 95 joules of potential energy and is about to jump off a 1.2 meter deck? What do we ask ourselves? What do they want us to find? Dun, 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 dun. What is the mass of the dog? So we know m equals, we need to find our formula. Again, go look at your formula page. You should get mass equals GPE divided by m. Oops. Erase. Divided by GH. Sorry about that. And again, this is a manipulation of our original GPE equals mgh formula. Let's fill in our numbers. Has 95 joules of potential energy, so that will go on the top. We're going to divide that by gravity times height. What's G? Always on Earth? 9.8 meters per second squared. We want to multiply that by the height, a 1.2 meter deck. Are we squaring any of our numbers? No. Remember, the squared is part of the units. It's meters per second, which we abbreviate meters per second squared. Again, make sure you do your 9.8 times 1.2 on the bottom before you perform the division. If you put it into your calculator correctly, you will get 8.1 as your numerical value. Now we need to figure out units, so let's think about it. We're solving for mass. What are the units for mass in our energy calculations? Kilograms. All right, let's look at our last problem, number 5, for potential energy. A 98 kilogram astronaut has 763.5 joules of potential energy while standing on top of a 2.1 meter space vehicle on Mars. Whew, that was a mouthful. What is the acceleration due to gravity on Mars? Dun, dun, dun. Acceleration due to gravity. They want us to solve for G. Remember we said G is 9.8 meters per second squared if you are on Earth? Well, now this astronaut is on Mars. So what is the gravitational acceleration? Go back and look at your formulas. G equals GPE divided by mh. Let's figure out what all these numbers mean. We have 763.5 joules of potential energy. So let's fill that in right here. Our mass is a 98 kilogram astronaut. Our height, 2.1 meters on top of the space vehicle. Now we need to plug in the numbers. Again, make sure you do your 98 times 2.1 before you do the division. Find that information first. If you put it into your calculator correctly, you will get 3.71 as your numerical value. What are our units? Remember, gravity is an acceleration. What are our acceleration units? Meters per second squared. If you forget the squared, it is incorrect. It is meters per second per second. All right, so if we look, it says the gravity on Mars is 3.71 meters per second squared, which means it is less than that of Earth. Let's look at some kinetic energy practice problems. We still want to show our formulas, our work, and a final answer with units. Number 6, what is the kinetic energy of an object with a mass of 5.2 kilograms that is traveling at 10.9 meters per second? What are we finding? What is the kinetic energy, KE? All right, now you're looking at the bottom set of formulas on your Intro to Energy Calculations page. And we only have one to solve for kinetic energy, 1/2 mv squared. Remember, in your calculator, you can put 0.5 if you would like. Same thing. So 1/2, we don't need to find anything there. It's just 1/2. We need to find the mass, 5.2 kilograms. Velocity, it's traveling at 10.9 meters per second. That is our velocity. And what do a lot of students forget? The squared. The squared is not part of the units there. Sorry about that. There is an interruption over the intercom. All right, so what was I saying? I said a lot of students forget to square the velocity. Remember, the velocity squared is part of the formula, not part of the units this time. So what does squaring mean? It means you multiply the value times itself. So you should do 10.9 times 10.9, then times 5.2, then times your 0.5. And there's another announcement. Sorry about that. All right, if you plug that into your calculator appropriately, you would get an answer of 308.9. And then we have to think of our units. Energy should tell us that we want it in joules. All right, let's look at number 7. How fast is a 1,200 kilogram car traveling if it has a KE of 1350 joules? How fast? They want us to find a velocity. So if you go and look at your formulas, velocity equals the square root of 2 times the kinetic energy divided by the mass. All right, let's fill in our numbers. Kinetic energy, it says right here, a KE of 1350 joules. So let's put that right here. We're going to divide that by the mass, which is right here, 1,200 kilograms. All right, now make sure you solve for everything underneath this square root symbol. So put 2 times 1350, then divide it by 1,200. Then what you want to do is find the square root key on your calculator and take the square root of this entire value. If you do that correctly, you will get 1.5. And it's velocity, so what will our units be? Meters per second. All right, let's look at number 8. What is the mass of a bee traveling at 15 meters per second if it has 5.6 joules of kinetic energy? What is the mass? M equals. Now, you do have two different mass formulas. This is under the section of kinetic energy, so that kind of gives you a clue that you want to use one of the kinetic energy formulas. But let's say I didn't specifically tell you that it was kinetic energy. How would you know which mass formula to use? You need to look and see what information the problem gives you. They give you velocity and they give you kinetic energy. That tells you that you're using this formula. Mass equals 2 times kinetic energy divided by velocity squared. So 2 times the kinetic energy right here, 5.6 joules. We're going to divide that by the velocity, traveling at 15 meters per second. And what do students always forget? The squared. Remember, it's not part of the units in this case. It is part of the actual formula. So you need to square the 15, or you need to times 15 by itself. So you should do 2 times 5.6, and then divided that by 15 squared. 15 squared is 225. If you put that into your calculator correctly, you will get 0.05, and it is mass, so what units? Kilograms. All right, that concludes our calculations. The next class, make sure you bring your textbook. We will be doing some more practice calculations, so you do not need to do any of these right now, but don't cross them off like I just did because we will be doing them during class. So again, have your textbook, have your calculator with you, and be ready to do some practice calculations.